Perfect. Looks like we're live. But hello, everyone. Welcome to another workshop for Hack AVS. Only 4 days left for the submission window to close, but we've got for you another workshop with Remi, who's the co-founder at Inco. Remi, welcome to the Hack AVS workshop, and we're super elated to have you. In fact, we were receiving a few queries about the Inco bounty, which is about killer use cases leveraging the confidential compute which Inco has bought. But without further ado, I'll pass on the stage to you, Remi. Feel free to elaborate on the bounty, any expectations that you have from the devs in particular, and then also feel free to take us through the technical workshop that you have for us.
Yeah, sounds good. Well, thank you so much, Mishka, for having me here. So today I'll just go very quickly over a presentation about what is Inco, and then we can dive a little bit deeper into the use cases as well. So what we're building at Inco is what we call the Universal Confidential Computing Network. Today, all the blockchains are transparent. So any L1, L2s, if you look at Ethereum, Arbitrum, Base, they all have one thing in common, is that all the information is public. Now, for us, we believe that there needs to be a minimum of confidentiality in order to drive for mass adoption. So just a couple of examples, today, if you use crypto as your bank account or payroll, everything is public. So this makes it very difficult for anyone to use crypto as their major bank accounts seriously. And also within a organization, if everyone's getting paid, let's say in stable coins, then everyone knows exactly how much everyone's making. And this is a bad practice in Web 2. Institutions and enterprises are still having a hard time entering the space. They have compliance reasons. They also have trade secrets. So they don't necessarily want to reveal how much revenue they're generating, things like that. And then lastly, there are just a lot of use cases that wouldn't make sense unless there is hidden information. So think of the card games, private voting, or blind auctions. So a lot of the blockchains today focus on solving the throughput problem, the cost problem. Where we believe to be, the next frontier is really around confidentiality. So this means that you can unlock both public and private blockchain use cases. So we'll dive a little bit deeper into what these use cases are. So with that, the cryptography we leverage is called fully homomorphic encryption, FHE. The idea of FHE is very simple. You can encrypt data and still compute on top of it without having to decrypt. So imagine if you encrypt the integer 10, another person encrypts the integer 20, you can add them together without knowing what they are. And so by the time you decrypt, you actually get the number 30. So on top of computation, you can also do comparison. So this can be quite useful for a couple of use cases that I'll go over in a bit. For folks who are non-technical, I don't know if there are people who are non-technical in this hackathon, but imagine you encrypt a cat picture. You can still manipulate the RGB values of each pixels by adding, dividing, multiplying. And by the time you decrypt, now you have a cat filter, basically. Or you have a picture with a cat filter. What makes FHE stand out compared to an existing solution that are more ZK-based, that some of you might be familiar, is really around the idea of composability. So what I mean by composability is the fact that you can store encrypted data on chain, but directly interact with this encrypted state in a permissionless manner. So imagine if we build some kind of predictions market, we can all submit our hidden price prediction of Bitcoin. We can still calculate the average of that price prediction together on chain using the blockchain as the shared private state or private layer. The challenge with ZK is a lot of these operations need to happen off chain. So ZK, has a prover and verifier type of setup, and these things needs to be so the prover has to happen off chain, and then the verification happens on chain. Now, if you have a use case that requires some kind of tallying of voting or of information, then this needs to be done off chain in a way that's difficult to achieve because you need a centralized prover to do the state transition on behalf of everyone. And that centralized prover basically cannot do state transition over encrypted data. It has to be over plain text. So there are quite a bit of challenges here. In FHE here, it's going to be a lot more straightforward and intuitive. So when you integrate FHE into an EVM called FHE VM, what you have essentially is the idea of encrypted data. So just the first line of code, this is just to represent a confidential ERC20. Instead of an address to EUINT, you have instead of a mapping of address to a EUINT that you typically have in an ERC20, what you have is a EUINT type. So EUINT just represents the encrypted type. And then if you do an ERC20 transfer, what you do is you pass in a EUINT amount. So you're doing a FHE addition of a encrypted amount to an encrypted balance. And then here you actually do a subtraction. So it actually reads and writes very much like Solidity. It's very intuitive. But more importantly, you actually don't have to learn to write complex circuits or require any off-chain centralized coordination. Here, everything happens on-chain. And then lastly, one thing I'd like to point out is we offer on-chain randomness, which can be quite useful for building games and such. So here, this randomness is actually encrypted by default. So you can also build things like card games or guessing games. Now, let's talk about use cases, which is probably what everyone is excited and interested in building on top of Inco. So gaming is definitely a big vertical. The reason why gaming is interesting is because today, all the crypto games are all transparent. So they are all perfect information games. Now, for a game to be challenging, you actually do need a minimum of hidden information in order to make it more challenging and more fun. So if you think about all the Web2 games that we have today, the ones that are actually fun require some kind of bluffing or some kind of strategic thinking, guessing. You can also spy on different players. You can also form secret alliances or some kind of fog of war. So this is where we historically have seen quite a bit of interest in the gaming side of things, crypto gaming, because oftentimes these games are just very easy to build. But more importantly, they are actually a lot more fun than your typical existing crypto games, which typically everyone has all the information on the public chains. Now, DeFi is also a very interesting vertical. So you can think of dark pools, blind auctions, private AMMs. You can also think of more innovative primitives. So what if you can build some kind of under-collateralized lending protocol because there is some kind of a private DID layer. So this is where I think there are a lot of innovation that can happen. Where you do need to be careful here with anything that's confidential DeFi is around the type of information that you leak. So for example, in the context of a private AMM, if someone swaps before you and you do a swap and someone swaps after you, they can technically guess how much you have swapped, right? Based on the before and after amounts. Now, there are techniques such as differential privacy that can help reduce the risk. So you can think of this as ways to add additional noise to the system. So I think it is a particularly interesting vertical to dive deeper into it for folks who are more DeFi savvy. On the enterprise, payroll is definitely an interesting use case. Today, all the payrolls are done in a very public manner. So in the context of a confidential ERC20, you can think of ways that you can create some kind of practical payment system for enterprises. And the idea here is you want to mask, for example, the amount that you pay out. And then there are interesting properties here with FHE where the flow of funds can still be traceable because everything happens on chain. So this is where it is both an interesting problem to solve, but also a very practical way of solving this problem. And then you have things like private cap tables, private treasuries, real-time prediction. I give an example of predicting the price of Bitcoin earlier. So there are interesting dynamics here where everyone can submit some kind of Oracle pricing or some kind of a price prediction, but they can't really copy each other, right? Because the answer that you submit will be hidden. So there could be some interesting dynamics here in terms of building a predictions market or some kind of Oracle service. And then you have things like private voting or confidential DID. So in terms of confidential DID, I do have another example later on that I can go deeper into. So this was a game that was built last year during ETH Global NYC. It's a fully on-chain mafia game. In this game, you have a hidden role. So you could be a doctor, killer, or detective. So essentially, it's a bluffing game. So we use the fully on-chain randomness generator to generate a role for each player. So this happens directly on-chain in a fair manner, and then only the player can view their own role. So this is a really good example of the novel type of experience that you can build on Inco instead of a existing L1, L2, is really this idea of the ability to hide roles, and then you can change the whole game dynamic, because you can start bluffing, you can start spying on people, you can start making secret moves. So this game actually is part of our arcade page. So if you go to arcade.inco.org, you can see there are a few experiences that you can try out. And so this game is actually part of the page. And yeah, highly recommend you trying it out. So now the question is, what if you want to build on top of an existing chain? So what if you want to stay on Base, ETH, and Arbitrum, right? So you can think of Inco also having the ability to be the confidential compute layer. So in this case, why don't you just, for example, build the poker logic of starting the game, folding, raising, calling. So all the major game logic can be on Base. And what you're using Inco for is really just the ability to generate and hide the cards. And so you can sort of decouple the logic and then spread them out across Inco and an existing chain. The benefit of that is, for one, you get to tap it into existing user base of Base, and more importantly, it just you can find ways to basically abstract away that Inco is running behind the scene for your end users, and so sort of make that experience a lot more seamless. Another gaming example here is, I think any battle mechanics, if you want to create a more fun version of, let's say, Axie Infinity, sort of like Pokemon, where you can have some hidden stats. So it could be the attack, defense, the speed. So that information could be stored on Inco. So when you trigger a battle mechanic, you can, let's say, multiply the hidden player stats by some kind of on-chain randomness and settle the battle outcome. So so this is the DID example that I want to give. So you can actually think of novel primitives around identity that's fully on-chain. So today, on the left, we have this concept of DID that's actually very static. So typically what happens is you KYC with a provider, and then they will send you a soulbound token that tests specific information, like, are you over 18? Are you in Europe? Is your credit score over 700? Now, with Inco, what you can build is this concept of dynamic DID, which is fairly novel. The idea of dynamic DID is that you can store encrypted data directly on chain. So imagine storing your credit score on chain, or your age, which could be your date of birth converted to timestamp, but encrypted. So imagine storing that information on chain, and then you can write specific query functions to reveal insights. So for example, you could reveal a function, is your credit score about 700, where all you do is comparing the encrypted credit score with 700, and then you can decrypt the insights. So in this case, maybe for something like Goldfinch, I just wanted to know I have a good credit score and nothing else, right? In this model, all the information on the soulbound token is completely public, which is quite inconvenient. In this model, with the concept of dynamic DID, you can actually selectively reveal insights, but also, let's say your credit score changes over time, like month by month, then these insights that you query could also change. And so this is actually very similar to what we have in Web2 with Google Auth, where when you connect to a specific application, you can give them access to, let's say, your calendar, but not your Google Drive or your contacts. So this is why we see this being an interesting project to build, also on top of Inco. And so if you were to deploy, let's say, a DID layer on top of Inco, and then with confidentiality as a service, let's say you want to bring this to a existing money market on Polygon, what they could do is they can query your DID layer and then whitelist specific users. Now, this is actually quite easy to use because we are compatible with existing Ethereum tooling. So you can use Hardhat, Remix, MetaMask, and For folks who are already familiar with Solidity, this should take it should take less than 20 minutes to onboard. We support quite a wide range of operations and comparisons. So you can do additions, subtractions, multiplications, divisions, also bitwise operations. And you can also do all sorts of comparisons. So it's really up to you now to unleash your creativity and think about all the novel DeFi things or gaming logic that you can build on top of encrypted data. So maybe to take a step back, why do we care about encryption on chain? We care about encryption on chain because if you think about the way you build things in Web2 as an engineer, if you were to build something like eBay, right? What happens is when people submit their bids, your private server actually wouldn't reveal everyone's bids in the open, and then you would just reveal the winner. Now, this is just not feasible on existing L1, L2s because everything is transparent. Now, what you have to do instead on a public blockchain is you have to encrypt your answers. And not only that, to apply specific logic on top of that encrypted data, this is where FHE comes in, is the idea that you can do all these operations and comparisons on top of the encrypted data, which allows you to recreate a lot of the typical Web2 user experience and logic. Previously I talked about the Google Auth, right, experience. These are the things that we're actually missing in Web3 because there is no concept of private state today. And so this is where, because now you're able to compute on top of encrypted data, there are just a lot of rooms for you to create more complex logic to replicate a lot of the Web2 experiences that couldn't work in Web3. Now, to get started, it's actually pretty straightforward. All you have to do is import these 2 lines of code. One thing I want to know that this slide is actually not the most updated. So here, make sure that you use the version that we specify in our docs, which I believe is FHCDN 0.3.0. But yeah, just double check our docs here. One thing that's important to note when you build using Inco is around information leakage. So what do I mean by information leakage? If you build logic on top of private data, you can't really use if and else statements because the branching of if and else statements would actually leak information about what the original encrypted data is, right? So to go around this problem, there is a primitive called CMUX. So it's a multiplexer. The idea of CMUX is that it works as a ternary. So if you pass in an encrypted Boolean or just a Boolean, it returns the first index of true or the second index if it's false, just like you would have in JavaScript. So let me go over an example here. So if you're to build private voting, it only takes 5 lines of code. So you pass in a encrypted vote count and also encrypted choice. The first thing you'll do is you compare if the encrypted choice is equal to 1. And what you get here is an encrypted Boolean. This encrypted Boolean, you can pass into the CMUX that will return the encrypted vote count if the Boolean was true, and 0 if it's false. But 0 is also encrypted. So in favor counter cast is actually either the actual vote count or 0, depending on what the choice is, the eBool is. Now you do the opposite for against counter cast, where you will essentially return 0 if it's true, and then encrypted vote count if it's false. So one of these 2 values would actually be the actual encrypted vote count. The other one will be 0, but you can retell from the outside. Now you add both of them to their respective tally, and so one of them would actually increment. And so this is how you can go around writing logic on top of encrypted data without a plain text if and else statement. And I would say this is one of the subtlety that you as a developer will have to learn. There are 2 decryption systems. So one is TFHC.decrypt. The idea here is that the MPC network would decrypt this value in a public manner. So anything you decrypt here will be known by everyone from the blockchain network, but also anyone in public. So you should only use this if you want to reveal a specific information to the entire system. So let's take the example of a poker game. At the end of the poker game, you want to reveal everyone's hand. You use TFHC.decrypt. But what if you want to, let's say, just view your hand? So this is where re-encrypt makes sense. So re-encrypt is used as a view function. The idea here is here the example is viewing your own hidden balance. What you do is you pass in two elements. One is a public key, and then one is a signature. So the public key is essentially the counterpart of a private key that you generate on the front end. So what happens is on your client side, let's say in your browser, you generate a temporary private key, and then you pass in this temporary public key that goes with the private key inside this view function. And so what happens is the validators basically do partial decryptions on the ciphertext and immediately re-encrypt using your public key. And so what ends up happening is you get basically all these partial decryptions back to your browser, and using the public key, you can decrypt and then recreate the plain text. So this is important to understand the difference, because in this system, only the clients, the user, can view their own balance. In this system, this decrypted value actually is revealed to the entire system. So make sure you know when to use these two functions. The other thing is, once you use this on the client side, you also have to pass in a signature. So the signature is EIP 712. The purpose is that you want to prove that you are you, that you actually own the address. So what happens is you use something like MetaMask to sign a signature to prove that you are indeed the owner of that EOA. And so you pass both of the informations into the system, and then what you get is you'll be able to decrypt the encrypted value in your browser. The third argument here is optional. The idea is some kind of default value in case the decryption fails. And then just from a high level, what happens on the client side is there is a client library, JavaScript library called FHEVM.js. So what this does is it helps you encrypt data on the client side and interact with the blockchain. So the way you hide data in FHE is called ciphertext. The anatomy of a ciphertext is essentially some data, some noise padding, and some data padding. So what you do is you essentially encrypt the data on the client side, and then you pass this in to the blockchain. And so what you have to know is that as you pass this data in, it's in the form of call data, form of bytes. And so you have to cast this into a specific encrypted type. So we have EUNs 8, 16, 32, and also EBOL. We'll support 64, 128 encrypted strings and addresses down the line. But as of now, these are the existing types that you can play around with. So as you cast these into specific hidden types, you can now use them to interact with other smart contracts. So this concludes the presentation. So this is a little bit outdated. This was a recent hackathon that we hosted at ETH Global. So just so you know, we have gotten quite a bit of submissions across gaming, but also infra. And if you do want to get additional ideas here, there is a Notion page full of ideas that we've come up with. So feel free to take a look here. We do have a Discord group, so if you have any technical questions, definitely feel free to reach out. So our team can provide technical feedback, but also feedback on your ideas. So if you're not sure whether or not your idea makes sense or would work on Inco, definitely talk to us. Same with our Telegram. You can also join our Telegram group, ask questions. And our testnet is called Gentry, so we can get some testnet tokens. So this is the link. And then you can find some useful docs here. So we also do have this arcade page that I mentioned earlier, where there are existing simple demos that you can try out, some novel experiences. So we encourage folks to encourage folks to explore docs and also try out some of the experience that we're already offering. So with that, this concludes the presentation. So let me double check to see if there are any questions I can potentially answer.
Yeah, seems like there are no questions at the moment. But yeah, definitely join the Inco Discord just to share ideas, jam with other developers, or ask any questions that you have later in time. We've also dropped the links to the documentation, the Discord, and also the Notion that Remi just shared. But there are also more things for you to go look at the hackathon page itself. there is a section called Bounty Details where you'll find more about the Inco bounty. Just feel free to go through that as well for additional resources. Yeah, and that was it. Thank you for attending the workshop today. Thank you so much, Remi, for spending the time with us.
Yeah, absolutely. And like I said, again, we're always happy to provide feedback, help out. So yeah, don't be shy. Just reach out to us on Discord.
Absolutely. Thanks a lot, Remi. Thank you, everyone, for
Yep.
attending. And I wish everyone building this hackathon a very good luck.
Thanks, everyone. Looking forward to your submissions.